got the QR code here for Slido, so that's where we're going to be managing the Q&A and any of the games. So just, hover that over your phone. Or if you want to go to slido.com and put in the code, let me just move out of your way. You can do that. So you put in the code ThreadSafe, and then you can have it open on your screen. It's up to you, sort of the best way to do it. So code or screen. So we're doing some prize giveaways for the quizzes. Going to be an icebreaker first with a prize, and then some prizes for the Q&As. Lovely. Cool. Do you want to
pass over?
Do you want to pass you over? Right, I'll hand you over to the guys now. Wonderful.
Hi guys, Gophers around the world, how are you? Really excited for today. Just a quick introduction from us. We're the two Joes here, the directors at Naviro. So very briefly, we specialise solely in Golang resource solutions, networks around the world, and really excited for a lot of events, both to start with the E-Series and then come into a city near you too. Very lucky to have Preslav here today. I'm sure you'll get a lot of value out of it. Katie's been working very tirelessly on the format for us. So Joe will just run you through the format schedule for today.
Yeah, I'm Joe G. You've probably been seeing a lot of my posts recently to get the numbers up here. So really glad to see that they've really accumulated over the last few days, and very happy to have you all here. So we're going to be kicking off with an icebreaker game. It's a Gopher Go card game, higher or lower. It's based on which ones you get right and how quickly you get right. There is a prize giveaway for the winner of that. After that, we'll be going into Preslav's talk on thread safety that you're all here for. He'll be talking for around 45 minutes and then hosting a live Q&A, question and answer at the end. So that is still available. You can still get your questions in on Slido, that QR tag that is just below down there. Get your questions in. Preslav will be selecting a couple of questions, and for those that are selected and the winner of that competition, there will be another prize giveaway. So make sure you're on Slido and getting those questions in. We'll be wrapping things up after the Q&A and announcing our next talk. So look, really pleased, can't wait to get it going.
Right, yeah, so we've got quite a few people signing in on here. I'm sure the main event is, of course, the tech talk from Preslav, but to be interactive in that, he has got some thread-safe questions on Slido, so make sure you kind of make use of the barcode and get active on Slido. We will also need it for this initial icebreaker game. You don't want to miss out. It's going to be good fun. As I said, prizes to be won as well. So we'll just give it another minute for everyone to get active on Slido. Last chance here. So once that's rolled down from the minute, we'll get straight into it, and then we'll kick on with the talk from there. So hope you guys are doing great. It's lunchtime here in London. We know we've got guys here from over in India, from Amsterdam, Paris, Berlin, all over the world, and our host joining us from Bulgaria too. So that whatever time of day it is, we appreciate you guys jumping on. There's going to be a lot of events kicking off over the next few months, so really good to have you on board.
Yeah, stay tuned. We have an Instagram account that's running. We have our Go Naviro Facebook and our Go Naviro LinkedIn page running with all of the updates on upcoming events. A lot of really cool GopherCon speakers that are going to be talking at those events, continuing with the question and answers, so you can get your questions into the guys. Make sure you stay tuned, and we'll be delivering a lot of information to the community over the coming weeks. So really looking forward to it.
Yeah, just one more thing. Joe mentioned about the Q&A that we'll run. You can submit a question at any time throughout the talk, and please do like the question that you really want the answer to. The most upvoted, the most liked question, Preslav will answer for certain, and also a prize for that too. And he'll do his best to answer as many as possible in the allotted time slots. So, right, without further ado, we'll kick things off with the game. So if you are active on Slido, we're going to be moving on to the icebreaker Gopher game now. If you've got any questions on this, last minute questions, if you're not quite sure, just drop a message in the chat. Otherwise, we'll kick things off in about 30 seconds.
Let's get it going, I say.
All right, quite a few late entries coming on board now. Click to join the quiz. All right, we got Sagar, Ali, Stefanos, lots of people coming in on board for this. So, right, is everybody ready out there? Good stuff, good stuff. All right, ready to start? Let's go.
I'm out, I'm in. 7, right down the middle. I do want to let everyone know these are random generated.
We're running out of time. Higher, lower, or the same?
The answers ourselves, so.
All right. So that was higher. Most people got that one. 75% of people got that one. Question number 2. 10 of spades, higher, lower, or the same? Are your options?
10 ball. It's going to have to be.
All righty. And the answer is
the same. You got people going for the same as well. 25% of you getting that right.
Well done. Very clever. Very clever. These were put together by our head of events, Katie. So yeah, we'll not quite random number generated. So keep your thinking caps on. All righty.
Oh, doing all right. 26% going lower there. That was all right.
Well, you're currently in 9th spot, mate.
I'm well behind.
Little update at the moment. Stefanos is leading the charge. 3 out of 3. All in just behind. Fastest finger, remember, if you do have the same number of questions. So next one, let's roll.
I'm going to go the same here.
Higher or lower, 6 or the same? Joe's gone for
I'm going the same. I'm going the same on this one.
And
lower. They've got
lower.
a curveball out there. 6%. See how there's people getting it.
Keep looking at the same card. Right, everyone's the same. But all right, roll on to the next one. 3, higher or lower, or the same?
Ooh.
We'll get a leaderboard update after that. And Joe, you were incorrect.
Incorrect.
It was the same.
67.
All right, Stefanos still leading the charge. 4 out of 5 right with 28 seconds. So quick and correct. Congrats, mate. Looking strong at the moment. Higher or lower or the same? 3 of hearts. Joe's gone lower.
I'm going lower on this one. I haven't got one right so far, so I've got to get this. Is it lower? Is it lower?
It's lower. There you go. You worked out the algorithm.
No.
So a few expletives in the chat, which was nice. Taking it seriously. It's what we like to see. We're all competitive over here. Higher or lower on a 2.
Get that chat going.
Let's go. Let's go.
Got to be. I like who's the one person that's gone for lower? I like that. Lower than the 2. That's ballsy. I like it a lot.
All right.
Oh, right. I think we're down
see
to
how that
final
leaderboard's
few.
looking.
What's the hashtag?
All right. You ready, Kate? Go for it. Leaderboard.
What we got?
Stefanos, 6 out of 8, still leading the charge, still in second place. Joe K has also moved up into joint second, just behind on fastest finger. All right, next question. Let's go.
One of the last questions here.
It's 9. Is it higher, lower, or the same?
I'm going the same.
Joe's gone the same. And the answer is...
I get people doing it, so I feel terrible. Higher, 20% of you getting it right. Sorry if I'm sort of leading you guys down the wrong path there. I was.
Did you win?
I hope so. All
right. Let's go. Everybody's pretty hopeful by the sounds of it.
19, yeah.
Let's have the big reveal.
The winner is, drum roll please.
Chris Stefanos
is it?
Led the charge from the start to the end. Congratulations, mate. $25 in Amazon vouchers on the way to you. So really, really well done. Thanks everybody for taking part.
Well done. Good. Right, without any further ado, sorry. Go for it, mate. Yeah, we're going to be introducing you to Preslav. So talk on thread safety. Don't forget to continue getting your questions in for Preslav on Slido. You can do so. He will be choosing some to answer at the end. We're going to pass you over to the man himself on thread safety. Enjoy the chat, guys.
Okay. How do we get off the...
Sorry, just a
panelist,
couple of technicals.
Mr.
Thanks a lot for the introduction, guys. Can you hear me? Can everyone hear me?
There you go, the main man. All right, enjoy, guys.
Thanks a lot. Can you guys hear me when I talk like this? I'm not sure. So want to double check the infra is okay first. Oh, nice, cool. So thanks, Naviro, for inviting me today to make this talk. I gotta say that the icebreaker was quite surprising. Never seen, a card game being played online like that. Didn't expect it at all. And I gotta say, I was quite behind in the competition. So starting from a low ground here. But anyways, at least I'll be able to contribute with the talk, although I won't get my gift voucher. Someone else will be the lucky guy, get it. The talk I'm going to discuss today is called Thread Safety in Go. So let's get started. I'm Preslav. Really nice to meet you guys. Unfortunately, not in person. Hopefully, at some point, I will start making meetups as well, rather than e-meetups, and we'll be able to chat in live as well. I'm a software engineer at Uber, and I'm also a technical trainer and speaker, doing all sorts of talks like this one. I'm maintaining also a blog and doing some open source work. So if you want to keep in touch, check those links out. Also, if you have any questions throughout the talk, please add them on Slido and upvote them. I don't think I'll get the chance to look at them throughout the talk. I'll try to monitor the chat. And by the way, Luis, I noticed that you're writing in the chat to panelists. I think people won't be able to see that message. Just a hint there. Okay. So if you have any questions, put them on Slido. I also monitor the chat from time to time. And first, let me discuss why this is called thread safety in Go rather than concurrency. The reason is that I feel that there's a lot of talks on concurrency. It's quite loved. Some people dread it. And Go is kind of novel when it comes to concurrency, right? Those who are in the language and have dealt with it for some time are aware with Go routines and channels. And that's quite of a novel concept, which not many other languages implement. But nevertheless, there are still some situations in which we have to deal with the old way of working with things when it comes to concurrency, and we have to make sure our applications are thread safe. So my role today is to introduce you to the topics which are often neglected when you first learn about concurrency in Go. As I just mentioned, I feel that this topic is often neglected. And my opinion is that learning about concurrency, learning how to spawn millions of Go routines and make your programs run in parallel without first understanding the fundamentals of thread safety, that's like riding a very fast car with 200 miles per hour without knowing about any safety measures, which is exciting indeed, but it can cause an incident, unfortunately. So the goal for today is to go through the fundamentals, which I feel that some of you might have. My expectation is that some of the things I'll talk about today will be known by some of you, while others will be something new. And you will recognize that there are some gaps, which hopefully I'll be able to help you fill today. But also, since I'm not going to be able to cover everything there is to know about this subject, I'm going to give you some guidance on where to go from here if you want to bridge that gap. So we'll talk about what thread safety is at all, why care about it, even when you have channels and Go routines. I see a question, what's the best resource to learn Go threads from? I'll get to that by the end, don't worry. Okay, we'll also cover some of the fundamental things you need to be aware of when you want to write thread-safe applications. And we'll explore them in a problem solution manner. That is, I'll first introduce a problem, which is common, you might probably encounter, and then I'll show you how you can resolve it and whether there is any problem at all. And finally, we'll cover the thing you asked about just now, Kushwant, which is where to go from here and how to up the ante in your knowledge about this topic. All right, so first let me discuss what thread safety means at all. So you can imagine that, well, not imagine, it is a fact that when you have classes which are safe, it means that they behave correctly. So if you have some class which is expected to authenticate the user, they should authenticate the user. If you have a class which should fetch some data from the database, it should do it based on the requirements it has. And I believe that once you master any programming language, you can write safe classes like that, which are safe in a, let's say, single-threaded environment. But then if you want to make those classes thread safe, that means that they should continue to work correctly, even when they're bombarded by a dozen of threads or Go routines in the case of Go. So this means that if you now take your class which accesses a database and fetches all the users from it, it should continue working correctly even when you access it concurrently from many places. So should you care about that at all? Like, is that an issue? You might have read about a bit about concurrency in Go. You might have discovered the topic of channels and the concept of like communicating by not sharing memory, but communicating. I don't recall the exact quote now, but the point is that you should avoid sharing memory, but instead communicate between threads or Go routines. So if you've heard that, you might think that you shouldn't really care that much about writing thread-safe classes or dealing with this. The other thing you might have as a misunderstanding is that you might be writing applications. Let's say you write web applications which do whatever, and you don't have a single Go routine written in that. Let's say you're not pretty confident in working with Go routines, so you don't leverage them. And by doing that, you kind of feel safe that you need not worry or know about thread safety because you aren't spawning any Go routines. Unfortunately, both of those situations are not correct. And in both cases, you might run into issues. This is a thing I often hear, that this is probably the bigger misunderstanding, that you don't really need to care or learn thread safety if you're just writing web apps where you're not spawning any threads or Go routines. That's a common misunderstanding, but that's not true, because even if you aren't writing any Go routines in your apps, you're already writing multi-threaded applications. Why is that? Because anytime you write a web server, a HTTP handler, or a gRPC handler, or whatever protocol you prefer using, you're probably already writing multi-threaded applications. Why is that? The reason is that this function, let's say get messages, it simulates some kind of a simple chat. This simple function doesn't actually execute in a single threaded environment. It's already bombarded by a lot of threads because every time a user makes a request to your server will not send one request at a time to your function. It will send those requests in parallel, and you have data which is accessed in parallel. And you need to worry about whether you're synchronizing access to that data. And what I mean by that is that you're accessing it in a thread-safe manner. This is an example of an application which is very simple. You're simply getting the user from some request header, and you're writing some message. You're essentially accessing this map here, which is a string to a list, and it represents the messages which are associated to users in your chat. It's a very simple application, merely 10 lines of code, and yet it's not thread safe. And if you run this application like locally, it will behave correctly. You won't see any issues. But if you actually deploy this in production and many users start using your application, chances are you will run into a lot of trouble. So by the end of this talk, my expectation, if this is something kind of unknown to you, if you didn't know this yet, by the end of the talk, you'll learn why this is an issue. Okay. All right, just monitor the chat a bit. Let's continue. Okay, so first, as I said, I'll discuss some problems you have when you have, we'll just explore several examples of code, and we'll see whether that code is thread safe and how we can address the issues. And the first thing we have to cover is, when do we even care about thread safety? When should you recall the things you will learn today and deal with them? Should you think about them every single line of code you write, or should you care about them in specific situations? So this is the first example we'll explore. We have two functions. One is called weekend safe, and one is called weekends unsafe. The purpose of these functions is to return a list of the weekends in a week. Very simple. The only difference between those two functions is that one of the functions is synchronized via mutex. The other function is not synchronized at all. So mutex is similar to like locks and mutexes in other languages. I expect that you have seen this in one version or another before. And my question to you now is whether which of these functions is thread safe? Are they both thread safe, or is one of them safe and the other is not? And one hint I want to give you here is that this data structure, which is the map in Golang, that data structure is not thread safe. So if you access that data structure from multiple threads in the same time, chances are you'll get in trouble. So that's the hint I have for you. And now I have, I'm going to start my own quiz in Slido. So please either join if you haven't already, or just open your tab in your phone again. And wow. Oh, so someone actually started the quiz already. Thanks a lot, somebody. That's really helpful. All right, so I see that people are already interacting with the quiz. I see that most people voted that weekend safe is thread safe function. A huge portion of attendees voted that both of the functions are thread safe, and some of them vote that weekends unsafe is thread safe, or neither is thread safe. Okay, so very mixed results. Very mixed results. One clarification I want to make is that these functions, imagine that they're multiple Go routines, like 10 Go routines at a time are invoking them constantly. So have that in mind. That's the way those functions are used. It's not like just one of them is called at a time. Okay, so 21 attendees voted. We have, yeah, I think we have enough people who have voted already. So I'll actually show you the correct answer. The quiz actually got lost. Let me try again. So I'll mark the correct answer now. Okay, and Surprise, surprise. Actually, both of the functions are thread safe. So I kind of deceived you there when I gave you that hint. And most people voted that weekend safe is thread safe. But that is actually, it's good that we have such results, because that means that you might now find out something you haven't known before, and you'll get value in the end from this talk. So I'm happy to see those results. Now in these two functions, my question was which one is thread safe? And let me go back. And actually both of them are thread safe, meaning that regardless of how many threads access weekend safe or weekends unsafe, they will always behave correctly. They will always return the correct result, and you won't have any issue. Even though both functions are using a data structure which is not thread safe. So why is that the case? Well, recall that what we wanted to cover is when you should care about thread safety and all. And the moment you should care about thread safety is when you're accessing shared mutable state. So if you have two threads or coroutines, you have different parts of memory you can access. You can access the local variables in your function. You can access some variables which are perhaps not local for your function, but somewhere in the heap. But they aren't shared with other threads. And you can access those kinds of variables which are actually accessed from multiple threads. And the only point in which you should care about thread safety is when you're accessing shared state. So if you're just accessing a local map inside your function, you don't need to worry about thread safety at all. This code is already thread safe because every coroutine which invokes this function will create a new map, a new instance of this map, and modify it. And since this map is local to the thread or the coroutine, there is no chance whatsoever that another thread will access the same map. Every thread will work with its own map. If, on the other hand, we have a situation like this, where the map is not local for the function, it's actually static for the whole package, then you have a thread safety issue. Or you should worry about thread safety issue. You don't necessarily have such, but you should think about them. This is the difference between the two examples. This one, the map is shared by all functions. And when multiple coroutines involve get messages, they will work with the same map. While in this example, that map is local for the function. So that's the first takeaway I want you to have in mind. You should care about thread safety only when you're accessing shared state. Okay, and the second concept I want to cover today is atomic access to shared state. Like, how do we, if we have shared state and we cannot avoid it, how can we guard it? How can we prevent any thread safety issues? And first, I'm going to show you the example where we have a structure which is not thread safe, and this is a hit counter which just has a counter which we increment and get. So it just has a setter and a getter, you can think of it. And if you have, let's say, multiple instances of this structure, actually, sorry, let me correct that. If you have one instance of this structure which is accessed from multiple threads, there is a chance that multiple threads will invoke this function and increment the counter at the same time. And when that happens, you might get into a situation where you increment the counter 10,000 times in parallel, but the result you get in the end is not 10,000, it's something less than that. While in the other case, where you have a thread safe structure, when you hit that thing 10,000 times, regardless of how many threads are touching that code at the same time, you will get the correct result. So this is an example of a class which is safe because it behaves correctly, but it's not thread safe because it doesn't behave correctly while being accessed by many threads. So why does that happen? Well, there might be multiple things which can go wrong. I'll just give you one example. Let me actually just stop screen sharing for a moment just to open a whiteboard which I use to store some notes as well, which I don't want to expose. So let me wait for this thing to open. All right, cool. Okay, so sharing the screen again. So if I take this thing and I paste it here, what can go wrong? Imagine that we have one thread which comes here and invokes this function. And what this thread will do is it will, let's say, assign this value to some variable. It will increment it by 1. I should have used a smaller, just one letter because it's hard now to write. And finally store the value back. This is how ++ works under the hood. It doesn't work as a single operation. It's actually multiple operations which are happening at once, or at least sequentially, but it's just hidden behind this syntax. So what can go wrong? Let's say a thread or coroutine enters hit, and it invokes this line of code, getting the counter. So what thread 1 will have in its state, let's say the counter is equal to 5 initially, it will take 5, and it will now proceed to execute this line of code, which is incrementing the value by 1. So it increments it by 1 and it becomes 6. But before it invokes the final line, which actually persists the result, what happens is that another thread might enter this function. It will again get the current value which is stored in the counter, which is actually still 5. It's not 6 yet because the first thread, it hasn't persisted its result yet. So that's why we're getting 5. The second thread will increment that value by 1, so it will become 6. And finally, the 2 threads will invoke one after another, let's say, this thing here, which is persisting the result. And the final result will be that the counter, initially which was equal to 5, first will change its value to 6, and then will change its value to 6 again, because both threads calculated that result. And whenever that happens often enough, you get to the situation where you get an incorrect result. So this is just an example of what can happen. The thing with concurrent applications, which are not thread safe, is that these problems are usually not reproducible all the time. They aren't also deterministic. If you run this example at home, you might actually get lucky and your application will work correctly. But if you execute it on my machine, it might not work correctly. Or if you execute it now, it might work, but like 1 day from now, or when the hardware is under pressure on your server, it will work differently. So that's one thing to have in mind with thread safety issues. And how can you fix this? Going back to the original question, if you have shared state, how can you fix access to shared state? And the thing you can usually do is you can use a mutex, which is the way to synchronize code inside a Go application. And you're going to hear me say this a lot, synchronize. You can think of synchronizing and locking codes to be related, not necessarily the same, but in the for the context of this lecture, let's say that the same. But the point here is that what we're doing is we're getting a lock. We're saying, okay, I want to lock this section of code, which is incrementing the counter, and only after I'm done incrementing it, I will unlock it. What this primitive will do, the mutex, it will prevent a second thread which enters this function to execute it before the first one is completed. So this means that when you're using this structure, when you're using this primitive, whenever the second thread tries to invoke this function, it will actually have to wait for the first one to finish first. And only after the first one has persisted its result, then the second thread can enter, get the modified result, which is 6, and increment it to 7, and hence you get the correct result this time. All right, cool. So that's the basics of how you can make sure when you have shared state that it's you're safe with it. If you have no idea, if you have no better way of dealing with shared state, this is your default option. Okay, but as I said, this is the standard way to deal with this stuff, but it's not the only way. There are other options as well, which are often better. I'm going to cover some of these, and I'm going to give you some guidance about how to learn about others. The first thing, which is used most often in applications like this, is a technique called delegating thread safety. What this means is the following. Let's say we have a structure called phone book. It has a map between a name and a user's phone. And this is shared state. This phone book might be accessed by multiple threads. So you have to prevent shared access to this structure. So one thing you can do is the thing I just told you. You can use a mutex, and whenever someone gets or sets the phone number, you're locking the functions and waiting for the previous thread to finish, if there's a new one waiting for accessing these functions. So that's one way to deal with this problem. But there's a different way as well. In this case, we have something called sync.map. And what sync.map is actually a data structure which provides you the same interface as a normal map. But the difference is that this data structure provides you a thread safety guarantee. If you open the documentation of this structure and read it, somewhere along the documentation, you will see something mentioned which says, this data structure is thread safe. This means that the responsibility of guarding the shared state is moved, it is not the responsibility of your code, it's actually the responsibility of the library or data structure you're using. And in this case, we have the same structure, but we don't have a lock and we have a synchronized map. And here we're getting the key, just like we would do on a normal map, or storing a value inside this map. And here notice that there are no locks anywhere, and yet we're still using shared state. But even so, this code is thread safe because you're leveraging delegation of thread safety, because you're using a library or a data structure which is already thread safe. And whenever you're writing applications and you want them to be thread safe, the easiest way to achieve that is to use such structures. Whenever you have some kind of a shared state, which is a map, think about whether that will be accessed by multiple threads. And if it is accessed by multiple threads, then you might leverage sync.map, because once you leverage it, it will be very easy both for you to maintain this code and for newcomers. If you're a newcomer to this code, even if you don't know anything about thread safety, there's a high chance that you'll be okay and you'll be able to work with this code base because the thread safety is taken care of. All right, so to recap this part, when you have delegated thread safety, it means relying on the thread safetiness of the objects you use. But it's also applicable to third-party packages. For example, if you're using GORM, which is the most popular Go ORM library, that library is thread safe. This means that you don't need to care about locking access to the library, and your applications in most cases will be okay. You won't have any issues with them. So the takeaway for you here, to put this in practice, whenever you're writing your next project and you're writing in a multi-threaded environment, which often is the case when you write web applications, choose your packages based on this criteria. Are they thread safe or not? And if not, what do you have to do in order to guarantee your application will be okay? But unfortunately, there are some more complicated operations you still need to be aware of. And that's compound actions, most of them. Let's say we have the previous example with the phone book, but we enhance the logic a bit. This time, whenever we set a new phone number, we'll first check that user already exists by this phone number. And if it doesn't exist, we'll store the new phone number. Again, we're using a thread safe data structure, so the operations themselves are thread safe. However, when you have a compound action, meaning multiple actions which are part of the same, let's say, bigger operations, you still need to synchronize that part all together. That you still need to synchronize those two operations together. In this case, the problem with this code base, with this code, is these three lines here. We actually have two operations here. One is checking that the user exists, and the other is storing the user. And what can go wrong here? Well, what can happen in this case is that, let me paste it here. What can happen in this case is that thread number one might execute this code here and get the user. Let's say it doesn't exist. So there is no user in this synchronized map yet. So it will move on and execute this line here. However, right before executing that line, another thread comes and reads whether the user exists or not. Since the first thread hasn't stored the new user yet, this other thread will indeed see that the user is not stored in the data structure yet, meaning that it will again proceed to the next line. And suddenly you will have two threads which will add a phone number to a user at the same time. So if you have a user with the name P, one thread might try to assign it the number 1, 2, 3. I won't actually specify a real number in order to save some time, while another thread will assign the number 2, 4, 3. And which will be the resulting number? Well, it really depends on the order of how it gets executed, how the threads get scheduled. Sometimes you will get this result, at other times you will get this one. You have no guarantee how this code will work. So this is an example issue where you have multiple actions which need to be synchronized together. And the point of this example is that although you're using thread safe data structures, you're not completely off the hook. You still need to think about these cases where you have multiple operations which are dependent on one another. So how can you solve this? In this case, the synchronized map has an operation called load or store. And most synchronized data structures have these operations where they're anticipating operations which are commonly used. For example, this operation is adding the value only if the key doesn't exist. In a normal map, you don't have that out of the box, but in a synchronized map, you have. And the reason you have this is not because it's more convenient. Truly it is more convenient to use this instead of the if-then statement. But the major reason for having this function is not that. The reason is that it allows the data structure to synchronize those two operations together, which will again preserve the thread safetyness of your application. So whenever you write your applications with thread safe data structures, again, be careful when writing actions like this. You still need to worry about whether those actions are compound or not. Someone is calling me all the time, but I'm ignoring them for now. All right, so to recap, actions from the same environment, which is a more formal way of describing this, need to be synchronized together. And the final thing I want to cover is probably the most misunderstood concept, and it's about visibility. I have some questions which I'll get to later. So we have this code which we're already familiar with. We have a phone book which has a lock, and it synchronizes the map it uses. Obviously, this code is not perfect because you can leverage the other data structure I showed you, but it's still okay because this code is still thread safe. However, let's say you notice a performance issue, and you think that the problem is that you're using locks in this code base. So you're trying to optimize stuff. And what you're doing is you're only setting the lock whenever you modify the structure, and you don't lock anything when you're getting values from the structure. Why do you do that? Well, because reading a state will not lead to race conditions, let's say. While writing it can lead to race conditions. So why not just remove the lock in the getter and only add it in the setter? So my question to you is this performance optimization valid? Is it okay? Let me start the next poll. So go ahead, go to the Slido again and vote, cast your vote. Okay, so we have one person answered yes already. Let's see what the rest of the people will say. Okay, again, we're moving towards a mixed result situation. Although it seems that, okay, I was about to say that most people will say no, or most people would say yes, but actually it's in the middle a lot. So, so the outcome is not obvious. All right, so 13 people voted. I'll just proceed with showing you the answer. I believe that the rest of the votes will not be able to modify the status quo. The answer is that this performance optimization is actually not a good idea, and it will lead to your code being not thread safe. So in example, let me go back to the slide deck again. In example, this will lead to bad stuff. But the reason is odd, right? It makes sense that when you access something concurrently, if you're just reading it, you shouldn't really have any issues, right? But the thing is, you do have issues. And that is because there are two problems when your applications are not thread safe. First is dealing with race conditions, which the ones with like the ones I showed you. But the second thing is dealing with visibility. Here's an example which demonstrates what I'm trying to convey. We have two functions, which again are actually what happens here is that one thread executes this function and another thread executes this. So these two functions are executed in different threads. And what this thread will do is it will set some number to 42 and it will set a variable, Boolean variable to true. In the other thread, what you're waiting for is for that variable to become true. And once it is, you print the number. But there are some checks in place in order to print that something went wrong and you actually got the wrong number. So the thing with code which is not synchronized, in this case, these two variables which are not synchronized, is that there is the Go compiler, and actually there is no language compiler which gives you a guarantee out of the box that the results from one thread will be seen by another. You simply don't have that guarantee. Now, what's the reason for that? Well, there can only be hypotheses what can go wrong. But in a nutshell, in this example, when you execute it, what the result will be is uncertain. You actually either get the correct result, where this for loop ends and you get the number 42. You might get into a situation where the for loop ends, but the number is not 42, although you are changing that number to 42 in the other thread. Or you might get into a situation where this for loop never ends, even though the ready variable is already changed. And the reason is because the Go compiler doesn't give you a guarantee that a second thread will see the results of the first one. Why is that? What can go wrong? Well, for example, the Go compiler might see this and say, okay, you are executing a for loop against a variable which you never changed. Let me just apply this small optimization and replace this for loop with an infinite for loop, which doesn't have any checks to save some CPU bandwidth, and just do an infinite for loop unconditionally. The other thing which might happen is that the result of number might get persisted in some cache, but it might not get propagated into main memory, while this thing does. And if your threads are running on multiple processors, one thread might see this result, but it won't see this one, because that one is not propagated to main memory. And for code which is either single-threaded or synchronized, the Go compiler guarantees that you will see the results. But if you don't apply any synchronization whatsoever, it cannot provide that guarantee for you. So you might run into these situations. Anything can happen in a nutshell in this code. So that's why when you have state which is accessed by multiple threads, don't just think about whether those values can be modified concurrently and you might get wrong results due to race conditions. You should also worry about one thread seeing the results of another. If in this case you had locks in place, if you had a mutex around these variables, around this code base, you won't get incorrect results in any situation, because the Go compiler will see that you're correctly applying a mutex, you're synchronizing these variables, and it will make sure that any other thread will see the result, regardless of whether you're running in one processor, in 10 processors, across several machines, etc. So that's in a nutshell, probably the biggest misunderstanding about thread-safe applications. So to recap, these are the concepts I wanted to cover today. These are the most important things you need to know about thread safety. And you can get a long way if you know these stuff, but it's still insufficient, and you should delve a bit deeper if all these things are new to you. But hopefully you gain some, you realize that there are some stuff you don't know and that you need to bridge the gap in your knowledge. So this is still a big win. It's very dangerous to go writing applications without knowledge about this stuff, but believing that you do have it. Okay, so several things to remember for today. You care about thread safety only when you're dealing with shared state. If you have methods or functions which are stateless, they are thread safe, regardless of what data structures, libraries, or functions you invoke underneath. You don't need to lock anything, because that data is local for the threads which execute your functions. If, on the other hand, you have static variables or fields in a structure, then you should worry about thread safe issues. This is the example we saw initially. We have two functions, and one is locked, the other is not. You don't need to lock anything. Both of these functions will be correct, will produce correct result regardless of how many threads execute them, because they are stateless. They don't modify to any state. Okay, second, you don't need to worry only about writes. You need to also worry about reads. This is the example we saw before, where we tried optimizing the get phone number function and only log the setter. This is insufficient and might lead to bad results, because you aren't guaranteed that a second thread will see the results produced by a first one. Let me stop that. Okay. right, when you choose to make thread safe code, oftentimes you're better off using data structures which provide thread safe features for you, because the mental overhead for you is a lot less. You don't need to think about where to put mutexes, where to avoid putting them. Just use a sync.map in this case and you're okay. But still you need to be careful about actions, which might be thread safe individually, but actually they should be thread safe together. In this case, we have these two actions which individually are thread safe because you're using a sync.map, but the fact that you're using thread safe functions does not make your function thread safe, because those two actions need to be synchronized together. This is the better version of that code, where you use load or store, which does the same thing, but other than just being simpler code and more fancy, it also makes sure that your application is thread safe. So is that everything you need to know? Unfortunately not. The good news is that you don't need to know as much as, let's say, someone dealing with Java has to, because Go is simplified in many ways, and there are a lot of details which you don't need to deal with. But you still need to learn about this stuff and know the fundamentals, because you can't get away with channels and every time. Sometimes you need to go back and use this old classic concurrency model, which has been with us for ages and everyone hates. If you don't understand these fundamentals well, you won't be able to understand channels or coroutines as well as you need to as well. And how do you get better at this? I gotta say, unfortunately, I haven't found a course or book which teaches these stuff in sufficient depth in Go, because most the resources focus on the Go aspects of concurrency, and trust that you know these fundamentals, which I demonstrated today. But if you don't know those fundamentals, before going and learning about the specifics of how Go concurrency works, you need to learn these things beforehand. And how can you do that? The best resource I know is this one. I'm sorry if you hate Java, but this is simply the best book on the subject, and it just so happens that it's written in Java. I would recommend this regardless if you're a Go developer, a Python developer, a C# developer, or whatever, because it's simply a book which not only teaches the Java specifics, but focuses on teaching these fundamentals which are applicable regardless of what language or technology you use. So that's why this is the next step if you want to get better at this subject. And if you want to explore these examples or get the slide deck for the talk today, this is the link you can follow. It links to a GitHub repo where I've uploaded all the things. And I also have a slide deck there as well. Okay, but in a nutshell, that's it for today. I hope this was fruitful and you found it interesting. And most importantly, it showed you some gaps which you eventually fill and get better at this topic. All right, so.
There, Louis Bolton here, technical consultant at Go Naviro. I take care of the French market. Merci pour tous les Français qui sont en attendance aussi. J'espère que vous avez bien aimé. Thanks a lot, Preslav. That was absolutely fantastic. You truly are real gen and one of the best in the business. I hope everyone found that super informative. I know we did. Absolutely loved it. So just going on to some of the questions. So just a heads up in the Slido. I know it says moderator, but those are questions that were pre-sent by some of you guys, and then Preslav just selected the ones he felt were really the best and the ones really people would want to know the answers to. So make sure you do like those questions. Last chance now. The most upvotes on one of those questions will be getting another prize. The winner of the question that was pre-sent is Domas Tamatsukas. So congratulations to you. You will be getting a $25 Amazon gift card via your email. So big congrats. And the question is, one for you, Preslav, how to write tests to make sure that code is thread safe, or at least write enough tests to allow race detector to find data races.
All right, so that's definitely a great question. Yeah, can you hear me? Louis, can you hear me speak? And I guess the rest, I'm not sure if unmuting myself is enough, but okay, I'll handle. So regarding the question, this is a really good one.
You're on mute there, Preslav. Sorry, let us just should be, yeah. Sorry, just changing you the host. So you are now the host.
Okay, can you hear me now?
Did you hear that question? Maybe a nod if you heard that question, Preslav? Yeah, you heard the question. Okay, we just can't hear your answer, unfortunately. Question was good. I know the answer is going to be as well. So let's just sort that out. Get you over to chat.
Can you guys hear me in the chat? Okay, so it seems that you do hear me. So the question is really good because similarly to the concept I told you about visibility, this one is very unknown as well. So rarely do people hear about writing tests for concurrent applications. And rarely do people do those kinds of tests. To be honest, I haven't really seen tests like that in production. I gotta say sadly. And there are, but you can do that. You can write tests which verify your code is thread safe. And it consists of spawning Go routines inside your scenarios and executing your code from multiple places. But there are many like caveats when writing those because it's not enough. Oftentimes it's not enough to just spawn a lot of Go routines. Let's say increment your counter 10,000 times and verify that at the end you get 10,000. Sometimes you can get away with that, but oftentimes it's more complicated than that. You need to use special tricks to do that. So I don't want to go into the details now of how to do that, but I can tell you that there is a chapter in the book I showed you, which covers testing concurrent application explicitly. It's very interesting. It was one of the most interesting chapters in that book. So if you want to learn more about that, go check it out. All right, so I'll go over the other questions I have in Slido. Moving from the top questions first. Being a novice Go programmer, I often find myself stuck in deciding how to structure my Go application. So I wanted to ask what kind of code structuring style you personally prefer, and what kind of architecture does an organization like Uber use? So it's a very good question, albeit not related to concurrency. I would say when structuring your application, there are frameworks you can use for that. You might, let's say, find talks on the internet which give you the recipe. Just use this and that. I'm not a big fan of that approach. And I think that you're better off learning the principles which go behind a good structure than learning the framework to do it. If you are interested in just getting a quick recipe about how to structure your apps, you can check out a talk on Gopher several years ago, which was from KatZN, called How to Structure Go Apps. She covers just that. Not into too much details as I'd like to, but she is confined by the talk. The good thing about it is that it gives you the precise recipe. However, again, let me emphasize that I do believe that it's better that you learn the principles first. And a good resource for that, actually, a resource which covers that, I can't say it's good actually, is a book called Clean Architecture. It's written by Uncle Bob Martin, the guy who wrote Clean Code as well. And it covers the exact principles you need to know in order to structure your apps well. But I can't say it's a great book because it doesn't write in a pedagogical style. That means that he writes the stuff you need to know, but you need to put a lot of effort to understand it. It's like those big technical books which you read. It sounds really smart, the things you read, but in the end you don't really understand it. It's not really obvious, and he doesn't provide enough examples, etc. But unfortunately, I don't know of a good book which covers those topics in the way, in a structured way, and is both, written in a user-friendly style, let's say. So that's why I recommend Clean Architecture. And on the other question, what we use at Uber, actually our Go code structure is based on that, the things which that book covers. So that's why I recommend checking that out. All right. That was the first question. Let me mark it as answered. Since Go has the ability to utilize CPU core. Oh, and by the way, please interrupt me if I'm out of time. I'm not sure.
We're just out of time there, Preslav.
Okay.
I hate to cut you short, but I think the responses to the questions were fantastic, and hopefully if there's a few more questions, if we could get some of those answered, we'll be delivering some materials after the event. We could get those answered. I wanted to just thank everyone for attending. Thank you, Preslav. Thank you for the responses today. We've been really happy and we've really enjoyed learning from you. I also wanted to give a special shout out to Sagar Somwain for his question that was the most voted around the amazing question that you read out first. So you'll be getting an Amazon voucher, $25 voucher that we'll send out to you as well, Sagar. So thank you very much. I'll just hand over to the Joes just to wrap up, and take care.
Hi guys. Back on again, just for a quick wrap up, as just echoing the words of Jack there. Jack looks after Amsterdam. So big shout out to the Amsterdam Gophers here. But really appreciate your time today. It's been great fun. We're going to condense a video together as well afterwards. So you've got a resource that you can turn to. I know there's lots of gems in there, and the results on the quiz was interesting, as well as the very, very fast-paced and high-energy card game to start with. So, look, big thanks to everyone being a part of this. Much appreciated. Joe, you let us know about the...
a couple of other things. Obviously, any questions that weren't read out. I know Preslav said he's happy to try and get some answers across to you guys, so don't worry if they weren't read out live on air. Press is happy to try and get those to you. Really big thank you to everyone that attended today and got involved in the quiz and the Q&As and everything. We do have another talk that's going to be coming up on the 5th of August, same time, with Andre Eriksson. He's going to be talking on the back-end superpowers and a number of other different areas. All of the information is available on the Go Naviro website under community. You can check out everything about those talks and the upcoming talks, and don't forget to register at the LinkedIn and the website to get updates directly to you on everything that's upcoming. And as Joe said, we're going to be delivering a wrap up of everything Preslav talked about today. So look, just want to say a big thanks to you, Preslav, on this. And look, can't wait to see you all at the next events.
Cheers, guys.
Thanks, guys.
Awesome. Really enjoyed it. As Joe said, Go Best Practices next with Andre. We also have another talk on concurrency coming up in a couple of months. And look, we want to make this an indefinite thing. So I hope you enjoyed it. Any feedback you've got, let us know, and we'll catch you at the next one.
Cheers, guys.
All right,
see you later,
guys.
Preslav. Take
Cheers,
care, guys.
guys.
All right.
See you guys.
Yeah.
Thanks.
Thanks. Have a nice day.